Hello everyone, welcome. This question, intersection of two arrays, part 2, tell you that you have two integer arrays nums1 and nums2. Ask you to return an array of their intersection. But the difference versus the part 1 is that you are required to return the element as many times as they show in both arrays, although you may return the result in any order. A brute force solution, as you can see here, will require a O m times n times n time complexity. How can we improve the time complexity here? Well, in general, if the question asks about the count of an element in a list, think of using a hash map. For example, for nums array such as 1, 2, 2, 1 as the elements, to count the number of occurrence for example, element 2, if you use the count method in the list, you have a time complexity of n in general. In contrast, if you can use a dictionary, then you can simply look up the key to the element 2, and then you see the value to be 2, and it has a constant O1 lookup time. Okay, now let's write the code. So first of all, we want to create a hash map for one of the two input nums array with the key is a unique element. Let's say nums1, and the value is the number of occurrence of that key. And to do that, we use a for loop. So for each number in the nums1 array, if that number is in the hash map, we know we'll increase the number count by 1. If it's not, then the count is initialized to be 1. And now let's apply the hash map to find the intersection. To find the intersection, we also want to create a resolve empty array, and then we iterate through the number in the nums2 array, and we ask where the number in the nums2 array is already in the hash map, because if it's in a hash map, we know it's a common element, and we will append that number to the results array, and we decrease, importantly, we decrease the count of hash map by 1. And so we're only doing this if the count is larger than 1, then we do this. Okay. And that will give us the intersection, and we can now return the result. So let's test this code. So it's evaluating, and done. 32 milliseconds, pretty good. And now finally we'll analyze the complexity here. So this has a time complexity of O m plus n, mainly because the hash map here, we iterate through the nums array. So this one gives us OM, and we also iterate through the nums2 array. So this gives us ON, and the other part has a O1 time complexity. So the time complexity is OM plus n. And for space complexity, it will be the hash map, OM for the hash map, And the result also have a minimum between m and n, and that's our space complexity. There's another possibility other than use a hash map as we just described. But what if nums1 and nums2, let's say they are already sorted, okay? If the question provides you the fact that they are already sorted, then you should consider use a two-pointer solution. In the two-pointer solution, we initialize two-pointer I and j. They point to the first element in the two nums array respectively. The point of doing that is for us to use the two-pointer to traverse through the true nums array, to traverse through nums1 and nums2. And then we also want to initialize an empty array result. And while the I less than the length of nums1, let's do a traversal here, and j less than the length of nums2. We want to see if the elements they point to are the same or not. If they're the same, we know we can append the common element to the end of the results array and then increase I and j by 1 as well. If the nums1 I greater than nums2 j, we know j need to have something to catch up to I. So, or the nums2 array, once the element will be able to catch up with I. So we increase j by 1, and finally we increase I by 1 because the nums1 I is less than nums2 j. We want to increase I to see it will catch up with nums2 j. And that's it. Finally, we'll return the result. And let's test this. And it's judging and it's done. So the time is 28 milliseconds. Now let's analyze for complexity here. So the nums1 dot sort, the method has a time complexity O n log m space complexity from O log m to OM in general, and similar for the other sorting. O n log n space from O log n to ON. And this one, the while loop here, the time complexity will be the minimum of m and n, and so really the sorting is the upper limit. So our total time complexity is dominated by the sorting method. So it will be O m log m plus n log n, and the space complexity will be dominated by the sorting method as well. O log m n to O n plus n, because in the other aspect the result stored up to O m, or the minimizer O and n, which is in general less than our sorting space complexity. And that's it. Hope you find the video to be useful. Feel free to subscribe the channel for more videos if you like. And see you next time. Goodbye.